Have you ever asked your phone about the weather or told a smart speaker to play a song, and just for a second, you kind of wondered, what's really going on in there? You ask a question, it gives an answer, it feels like magic, right? But behind that curtain, it's not magic at all. It's this brilliant, complex architecture that we are about to take apart piece by piece. So how does an AI actually think? How does it take our messy human requests and turn them into a clear, useful action? Today, we're going to pull that curtain back, and what we find inside is a blueprint. And this is our map. This is our blueprint for the journey into the machine's mind. We're going to follow this exact path, from knowledge to reasoning to learning and finally to decision-making. By the end, you won't just see the different pieces. You'll understand how they create a thinking machine. And like I promised, we'll keep coming back to this map at every turn. Okay, first stop on our map, the agent's memory banks. Because before an AI can think or act or do anything at all, it has to know things. It needs a library, a foundation of facts about the world. This is its knowledge base. But here's the trick. It can't just be a messy pile of data. I mean, imagine a library with no catalog system. It would be totally useless. The information has to be organized, and that whole process is called knowledge representation. It's really the art of structuring data so an agent can actually find what it needs and put it to work. Let's look at a couple of clever ways it's done. Okay, look at this. It's called a semantic network, and you can almost feel how an AI would see the world here. It's basically a mind map. The concept dog isn't just a word, it's connected to all these other ideas. A dog is an animal. It can be a pet. Or for a medical AI, a disease causes a symptom and is treated by a certain treatment. It's a whole web of understanding, all built on relationships. Another way to do it is by using frames. Think of these like structured filing cabinets for knowledge. You start with a general file, like vehicle, which holds basic facts like has wheels. Then, a more specific car file automatically inherits those properties and then adds its own details, like make and model. It's incredibly efficient. The AI doesn't have to relearn that a car has wheels every single time. Okay, deep breath. This looks a little intimidating, doesn't it? It's called formal logic. And yeah, it might look like complex math, but it's really about giving the agent hard, unbreakable rules. This isn't some flexible mind map. This is a statement of absolute mathematical certainty. So all that complex notation simply means this. For all things X, if X is a human, then X is mortal. Simple as that. By encoding rules this way, the agent builds up a knowledge base of provable facts, a solid foundation of things it knows without a doubt are true. All right, so our agent has its library. It knows things. Now, let's head to the next stop on our map, the reasoning engine. This is where the magic really starts to happen. This is where the agent takes all that raw knowledge and actually begins to think. The first and most classic style of thinking is called deductive reasoning. Think of it as top-down logic. You start with a general, ironclad rule. All men are mortal. Then you introduce a specific fact. Socrates is a man. The conclusion is just inescapable. Socrates is mortal. If the first two things are true, the conclusion is guaranteed. It's pure, it's precise, and it's certain. But what if you don't have a perfect general rule to start with? Well, then you have to reason from the bottom up with inductive reasoning. The agent observes specifics. The sun rose yesterday and the day before and last year. From that mountain of evidence, it forms a general theory. The sun will probably rise tomorrow. And notice that word probably. It's not a guarantee, it's a probability. And this right here is the engine behind almost all of modern machine learning, finding patterns in data to predict the future. And finally, we have my personal favorite, abductive reasoning. This is pure Sherlock Holmes. The AI isn't starting with a rule or a pattern, it's starting with a clue. The observation is, the lawn is wet. It then works backward, searching its knowledge base for the most plausible cause. The sprinkler wasn't on, no one was watering, so the most likely explanation is, it rained last night. It's the art of finding the best explanation for the evidence you have. So our agent can know things, and it can think.
It's pretty smart. But what happens if it's wrong? What happens when the world changes and its perfect logic leads to a flawed conclusion? What happens if this one part fails? To be truly intelligent, an agent can't just be a static thinker. It has to learn.
And that brings us to the final two, very connected stops on our blueprint: learning and decision-making. You can't really have one without the other. This is what transforms our agent from just a simple calculator into a dynamic being that actually improves with experience and chooses the best path forward. So, how does an agent actually get smarter? Well, there are three main paths to learning. First is supervised learning. That's like studying for a test with a teacher who gives you the answer key. The AI learns from perfectly labeled examples. Then you've got unsupervised learning, where you just throw the AI into a massive library with no instructions and say, go find the patterns. And finally, maybe most powerfully, there's reinforcement learning. This is just like training a puppy. Good action, you get a reward. Bad action, no reward. The agent learns what works through pure trial and error. Okay, so after the agent learns, it has to decide. How? It doesn't just guess. It uses something called a utility function to weigh its options. Kind of like we would. Look at this travel choice. The flight is expensive. The road trip is cheaper. Seems like an easy choice, right? Well, not for an AI. It weighs everything. It assigns a value to price, sure, but also to comfort and convenience, based on what it's learned about what its user prefers. It then calculates a total utility. Think of it like an overall happiness score. And here, the road trip wins, not because it's the cheapest, but because it delivers the best overall value. That is rational decision-making in action. Our blueprint is now complete. We have an agent that knows, thinks, learns, and decides. But in the last few years, something new was bolted onto this engine, a technology that acts like a supercharger for every single component we've discussed. And that upgrade is generative AI. So how does this supercharger work? Well, in a few pretty incredible ways. It can create synthetic data, basically inventing new examples to help the agent learn faster. It can simulate complex scenarios, playing out millions of futures to find the best one. It enables the natural, human-like conversations we all expect now from AI assistants. And, maybe most amazingly, it can generate truly creative solutions, dreaming up ideas that weren't even in its original programming. Let's see how the whole machine works together. A user says, "Hi, I want to book a flight ticket." Instantly, the agent's knowledge base tells it that a flight needs a destination and a date. Its reasoning engine deduces that it has to ask for that information. Then, its Gen AI supercharger kicks in, crafting a natural conversational reply. When the user responds, the agent learns the details, and its decision-making module concludes the best action is to book the ticket. Every component we discussed working in perfect harmony, all in one simple conversation. So, we've completed our journey. We've explored the memory, the mind, the learning process, and the decision-making core, all of it turbocharged by generative AI. Now, let's pull back and look at our blueprint one last time, just to see the whole system humming. And there it is, the loop of intelligence. It all starts with knowledge. That knowledge is fed into the reasoning engine to produce a thought. But every decision creates a new experience, which is then fed back into the learning mechanism. That learning updates and enriches the original knowledge base, and the loop begins all over again. It's not a straight line. It's a constantly spinning flywheel, getting smarter with every single rotation. This, right here, is the essence of a digital mind. So, we've deconstructed the magic. We have our blueprint for an AI that can know, think, and learn. But that leaves one final, kind of haunting question. We've built an agent that can know the world. But can it ever truly know itself? Can it reflect on its own thoughts and question its own existence? We've seen how this all works in theory. But what happens when this system is pushed to its absolute limits? That's a story for next time. Hurry, hurry.